Okay, so today should be Friday, March 28th. Should be the last video for Chapter 3. Before we come back next week, work on some test review stuff, take a short Chapter 3 test, and then we'll spend a couple days working on the review book, talking about what to expect on the practice exam, first one that'll start on April 5th. All right, so for today, picking up where we left off, does seat location affect grades? So many people believe that students learn better if they sit closer to the front of the classroom, so does sitting closer cause higher achievement? Or do better students simply choose to sit in the front? So to investigate, a stats teacher randomly assigned students to seat locations in his classroom for a particular chapter. At the end of the chapter, he recorded the row number, row 1 being closest to the front, test score for each student. A least squares regression was performed on the data, a scatter plot, so we have a scatter plot with a regression line added, we got a residual plot, and we got a computer output for that regression. So, part A, what is the equation of the least squares regression line that describes the relationship between row number and test score? So, remember from these computer regression or mini-tab outputs, the top row is talking about the y-intercept, the bottom row is talking about the slope. So in terms of an equation, y hat equals a plus bx, the a would be the y-intercept. So y-intercept coefficient, 85.706. And then the slope, which was a negative slope, so negative 1.1171x. So then defining any variables that we use, so y hat would represent the predicted y. Okay, which in this case, the predicted y, the y-axis was score. So this would be predicted score. And then the x is representing the row. All right, part B, interpret the slope of the regression line in context. So the slope was that negative 1.11 number. So when we interpret slope, we're saying for each additional x, so for each additional row from the front of the classroom, we predict a what? So we predict a what? Increase or decrease. So we would predict a student's test score to decrease because the slope was negative. So we're predicting it to decrease by 1.1171 points. Okay, so when you're interpreting slope for each additional x, we predict the y is going to increase or decrease by whatever the slope was. All right, part C, find the correlation. So the correlation is the R value. So from this mini-tab output, we are given the R squared value as 4.7%. So that means R squared, if R squared was 4.7%, taking that out of percent form, move the decimal point 2 places, we get an R squared value of 0.047. So then to get R, take the square root, take the square root. So R is going to equal the square root of 0.047, which is about 0.217. And then when we're finding correlation from R squared, we're taking the square root. We got to determine whether this correlation is positive or negative. Well, scatter plot was negative, slope was negative, so the correlation is going to be negative. Last part, is align an appropriate model to use for these data? Well, if we look back up here, it looks like, however weak the correlation here might be, it looks like these are roughly linear. There's no clear curve pattern to it. So scatter plot looks good. And then the residual plot, it looks like random scatter. There's no clear nonlinear pattern, there's no fan pattern. So yes, a linear model would be appropriate. Okay. So last thing here for today is to talk about specific types of unusual points. Okay, again, and when you're describing a scatter plot, we just have to talk about, whether there's a strong positive linear association between what and what, where when we talk about unusual points with that, we might say this one's a possible unusual point or there's no unusual points. You don't have to get specific as to what it is. These might just come up in a multiple choice question where you got to determine what specific type of point it might be. So high leverage points are points with high leverage in a regression that have much larger or much smaller x values. Okay, so they specifically have drastically different x values than the rest of the data set. An outlier in a regression is a point that does not follow the pattern of the rest of the data and has a large residual. So you might have a certain pattern of data, and then you got a point that's not following that data trend, be considered an outlier. Last one, influential. An influential point in a regression is any point that, if removed, substantially changes pretty much everything. The slope, the y-intercept, the correlation, the r-squared, the standard deviation. So like the removal of that point affects all of your metrics. All right, so in here, case one, this is just showing you the original data set, no unusual points. We've got our cluster of points down here. Okay, over here, so we've added this point in way out here. So is it high leverage? Is it influential? Is it an outlier? Well, it looks like these x values are all down between 0 and 7. This has an x value of 35, so it has a drastically different x value. So it would be considered high leverage. However, in terms of regression, it would not be considered an outlier because it follows the data trend. It's not off of the data trend, so not considered an outlier in terms of regression. And then it would also be an influential point. Influential point because it's drastically changing these metrics. Like R went from 0.41 to 0.94, R squared changed, S changed a little bit, but influential because it's affecting those other values. So that point we're considered high leverage influential. Okay. Case number 3 looks again like, okay, our data trend was here originally, so this point has an extreme x value, so it has high leverage. It also looks like it's influential. It changed these values. And because the original thing was here, I would consider this also an outlier, even though they've switched the regression line to be down here. I would also consider that an outlier. This one, so we got again original data here, now we got a point added up here. Well, it's clearly not following that data trend. So we got the trend here, it's off of that data trend, so it'd be considered an outlier. It would not be considered high leverage because the x value is the same as some of these points down here, the original points, so not high leverage. And also influential because it's drastically affecting these correlation, r-squared, and standard deviation values. All right, that, I guess there's one more example here on the next page. All right, then we'll be done. All right, so this one, scatterplot shows payroll in millions of dollars and the number of wins. So payroll and number of wins for Major League Baseball team 2016, along with the least scores regression line. The points highlighted in red represent the LA Dodgers. So this one over here was the LA Dodgers, and then the Cleveland Indians was right here. So that'll just be important for these next questions. So part A, describe what influence the point representing the LA Dodgers has on the equation of the least scores regression line. Okay, so what is this point doing to this line? Well, it looks like if we didn't have this point, the regression line might be there, right through the center of black points here. So it looks like this point is decreasing the slope. Okay, it's making that slope a little bit less, so it's decreasing the slope, and looks like down here, the original predicted y, or the y-intercept would have been down here, but with LA, it was up here. So having this LA point in here decreased the slope, which increased the y-intercept. Okay, part B, last question. Describe what influence the point representing the Cleveland Indians has on the standard deviation of residuals and the coefficient of determination. Well, because this point is so far from this regression line, it's increasing the standard deviation of the residuals, which in turn would decrease the value of r squared. Okay. All right, that should be it. So last notes for chapter 3. Again, we should have normal Friday classes today with no ISASS. I'll be back next week. We'll go through some test review on chapter 3, take a short test on Wednesday, work on some review book stuff, go through some exam reminders, and get set for practice exam on Saturday. Okay? I hope everybody has a great Friday.